Hi, everyone. My name is Ali. I'm a chemistry tutor with the Fresno State Learning Center. Today in this video, I'm going to be going over all the concepts related to uncertainty and sources of error in chemical measurements, which is part of your Chemistry 1A first lab. Some of you may be unfamiliar with chemistry labs, and um, that includes your blue book and your pre-lab and being able to complete the in-lab requirements as well as the post-lab requirements. So this first lab may be very unfamiliar to you guys, so hopefully I should be able to clear up any doubts and any other misconceptions that are going on with this lab. So our first lab is with uncertainty and sources of error in chemical measurements. Oh, just a disclaimer, this is from the 2017 Chemistry 1A lab manual. The information is very similar to the 2023 version. However, there may be a little bit differences, but refer to what you have in front of you. This will still be able to give you a good guide on how to approach this lab. So with your blue book, there are a lot of different components, and please refer to the blue book requirements on that we have on our chemistry tutoring library. That should give you the requirements and show you how to go through a blue book. But in this video, I'm going to be going over these important concepts regarding uncertainty and other calculations that we'll be doing in this lab. So first thing I want to point out is pay attention to your learning objectives and your experimental summary. Those are things you'll want to include in your introduction. Again, paraphrase all of this. Don't directly copy it. It's important to have in there so at least you have a baseline of what to follow in the lab. So a lot of this other stuff, discussion and theory, it's really important that you read this up and understand what we're actually trying to get at here. This will also help with your introduction, but more of it should be covered in the experimental summary. But this will really show you all the details. So in this, in the first part, in the first page, we have the discussion theory. This will tell you your units. Will explain things like units, context, uncertainty, things like that if you're unfamiliar or forgot it from lecture. So going on to our next page, we have our sig figs here. So sig figs are the most important part of chemistry, actually. You will have to do sig figs for the rest of your chemistry career. And even beyond, in physics, they do a lot of sig figs as well. So I want you to pay attention. So let's go over a couple of rules with sig figs here. So let's go over these examples here. Sig fig is any number that is usually not zero. So you could have 1, 2, 3, 4, 5, 6, so on, you know? Zero can count as a significant figure, but only in very specific situations. So in this case, leading zeros are never significant. If you have a zero in front of a decimal or before a decimal, in front of a decimal or after the decimal, most of the time they are never significant. And most of the time you'll see after the decimal, sometimes they can be significant, but we'll go over some examples. But those are called leading zeros. Leading zeros are never significant. Interior zeros are always significant. So you can, as you can see, 809, that is significant. We have to always include that in our calculations. A trailing zero, this is where we're having that leeway that we were talking about with the zeros. It's significant with a decimal point if it's behind a decimal point, but if it's a trailing zero before a decimal point. So for example, if you had 8090, that zero, and there's no decimal, by the way, 8090, that decimal, if there's no decimal, that zero behind that 9 is going to be non-significant. So only trailing zeros are only significant with a decimal point. Without a decimal point, they're not significant, as you can see in this other example right here. That's a perfect example. Awesome. So in your study guides, you may have to identify the number of sig figs or produce numbers that have the correct amount of sig figs. So keep that in mind. This is very important. And this sig figs really help us understand uncertainty. They express uncertainty. The last digit is always uncertain. That's why we include it. Okay, great. So we went over significant figures. Again, stop by the Learning Center if you want some more information, but this is a great example here. Please refer to it. Okay, so when we read a scale, we get a ruler, for example, and we try to measure something. We don't, for example, if something's sitting right in between, it might be at the mark, it might not be at the mark. You're unsure, right? You're uncertain. So usually we record this as what we know, but then we add an extra uncertain digit because we are uncertain. So in this example here, we are, let's say, weighing something on a scale. And we know that the scale can record up to three digits certainly. It can certainly record 3 digits. But it adds an extra digit at the end because it's uncertain. So that's why we record it as 2.5089. In this case, this would be 5 sig figs. So keep that in mind. When we're measuring something or graduated cylinder, you'll use that in the lab quite a bit. We look at the meniscus, right? We're looking where the meniscus is. We are unsure if that meniscus is maybe at that 0.5 mark or could it be at the 0.51 mark? We're unsure. So instead, why don't we just add 2.50 or 2.51 or 2.512, something like that, just to make sure that we have that uncertain digit. That is very important when we're reading scales. So keep that in mind. So there's some good practice here if you want to try that out by yourself. But remember to keep that last uncertain digit because we want to express certainty, but we're not sure. We have to express uncertainty as well. So keep that in mind. Okay, great. So experimental errors. Here are all the different types of experimental errors. In your post lab, in your conclusions, you will have to express experimental errors. You'll have to say, oh, what are some of the, did you have a technique error while performing the experiment? Did you have a method error? You have to write that up in every conclusion for your chemistry labs. It's very important to identify errors. So this is a great page to refer to. Read up on equipment, method, sample, technique, and context error, and try to identify the errors you made in lab. When you're doing the lab, try to identify those errors and write them up in your post-lab conclusion. There's also systematic and random errors, so also keep that in mind there too. Okay, and then now we have to do sig fig calculations. Now that is quite complicated. We have two rules here, the addition and subtraction rule, and we have the multiplication and division rule. Now, just some background behind this. The addition and subtraction rule, when we do this, remember, we're trying to express uncertainty. That's why we want to include it. But we want to also make sure we have the correct amount of sig figs in every answer that we provide to our professors, on our exams, everything, to express uncertainty as well. So with the addition and subtraction rule, there are two main rules that you should remember. For addition subtraction rule, keep the least amount of decimal places. Least amount of decimal places. And I'll showcase that in a bit to you guys. Multiplication division rule, I want you to understand that you need to keep the least amount of sig figs. That's what really matters here. Keep the least amount of sig figs. And I'll show you some examples here. Okay, great. So now I'm going to show you some examples using the addition, subtraction, and multiplication division rule for sig figs. So I'm going to write some stuff down on the board here. Sorry, give me 1 second. There we go. All right, sorry about that. I was just fixing up my whiteboard. So I'm going to write some examples down. 2.1573 plus 10.37. All right, perfect. So we have an example here, and we are using the addition/subtraction rule. That means that plus sign could also be a negative sign. Same rules would apply for sig figs here. So remember what we said. We said the least amount of decimal places. So let's count the decimal places. Remember, decimal places are after the decimal point. So let's count the decimal places in each number. So in this 2.1573, there's 1, there's 2, there's 3, and there's 4. 4 decimal places. Excellent, awesome. So let's look at the second number. There's 1 and there's 2. 2 decimal places. So whatever answer is, our final answer is going to have only 2 decimal places. Nothing more, nothing less. Doesn't matter how many number of sig figs are in this answer. We just care about the decimal places. So this is going to be like 12 point something. I'm just going to use x's to represent numbers. We're just going to put x, meaning 2 decimal places. There you go. That's all you need to know for addition subtraction rule. Awesome. Okay, then we have our multiplication and division rule. So let's use the same numbers. It doesn't matter whether we use one or the other. 2.1573 divided by 10.37. Now, the thing with this is that now we're going back to this multiplication and division rule, which states keep the least amount of sig figs. So let's count each sig fig in each of our problems here, or each of our numbers. There's 1, there's 2, there's 3, there's 4, and there's 5. 5 sig figs. Okay, let's count the other one. 1. Now, is that 0? Think about it. Is that a sig fig or not? Yes, it is a sig fig. It is an interior 0. So we count that. So 2, 3, and 4. Okay, we have 4 sig figs there. Awesome. So whatever our answer is going to be, I'm just going to use x's again. We are just going to have 4 sig figs, whether there's a decimal or not. So our answer will always have 4 sig figs based off of what we have here. The least amount of sig figs. Hopefully that makes a little bit more sense. Now, it gets a little bit more complicated because we are going to be doing compound operations. We might do addition and division in the same problem. In that case, stick with what you have. Don't round. Don't round anything. By the way, you also have to round with sig figs. So let's say we had 12.xx. Let's just say it said 563. Okay, that was our final answer. Let's just say that. That 5, we don't want anything after. We don't want anything after that x, right? The last x. But what we can do is we can round that x up because of that 5. Okay. And then we get rid of everything. So that's what's important. Okay, great. So going back to what I was talking about, compound operations. What you want to do is you want to do the first operation first. So let's say we had 2.1573 plus 10.37. Okay, and that's in parentheses, and it divides by 7.8. Let's just say that, okay? We do what we do here for the first part. We do what the top first, because that's in parentheses, right? PEMDAS, if you remember that. We do the same thing, addition subtraction rule. So we get whatever, 12.xx. And let's just say we get like some other numbers, like x, 7, 8, 6, 2. I don't know. Okay. What we want to do is we want to highlight, we want to just underline that last digit, the last uncertain digit that we're going to be including. Okay, we're not going to round anything yet because we want to try to get the most accurate answer, most precise answer. So just underline it for now. That's where you're going to be rounding, right? Then you do your second operation, which is your 12.xx7862 divided by your 7.8. Okay? When you do that, you'll get an answer. Okay? Whatever your answer will be, you're still sticking by the sig fig rule, 4 sig figs. So x point XX, okay? And remember where you underlined? That's going to be your last sig fig. That's going to be your last sig fig. And then you either round or you don't round or you stay the same. So that's the most important part. So don't worry about the compound operations. Still worry about the sig fig rules. So remember, least amount of decimal places. I'm going to write it down right here. Least amount of decimal places. And this is least amount of sig figs. Okay, remember that rule. Remember it for the rest of your chemistry career. Great. All right, let's continue moving on. Awesome. We covered sig fig rules, so remember that. Let's go to the next page. All right, we talked about rounding as well. We want to round to be precise. That is important. In compound operations, we went over that. Excellent. So the last thing actually that I want to cover that actually isn't mentioned in the 2017 Chemistry 1A lab manual, but it is mentioned in 2023, is standard deviation. That is very important. So I want to go over that real quick. So give me 1 second. All right, great. So we will go over standard deviation. So you might see this formula in your lab manual. It says sigma, by the way, this means sigma or sum xi minus x bar over, square, don't forget the square, n minus 1, take the square root of all of it, and that is your standard deviation, SD. Excellent. Okay. So now let's help kind of define all this stuff. So we talked about this term right here. That refers to sigma. Okay. Now, xi refers to a single data point. Okay. So let's just go, let me just make an example here. 1, 2, 3, 4. These are trials. And for our trials, we get 3, 4, 7, and 11 for our trials. Okay, those are the 4 numbers we get. Awesome. 3 is a single data point. 4 is a single data point. 7 is a single data point, and 11 is a single data point. So that's what xi is, and that's what xi gets plugged in for. 3, 4, 7, and 11. Okay. X bar refers to the average. So the average of these 4 data points. So 3 plus 4 plus 7 plus 11 divided by 4. Review some videos on average if you're unsure how to do that. Okay. And your n refers to your number of trials. So in this case, we had 4 trials. So we would have 4 trials. All right, perfect. That's literally all we need to know now. Now we just start plugging things in. So I'll show you how we set this up. So break this up into piece by piece. Don't do it all together and don't plug in your calculator all together or it's just going to become a mess. You want to try to be able to do this as fast as possible and it's understandable. Okay, let's start with the first part. We'll start with the top calculation here that I circled. Okay. So we're going to plug in our single data point, 3 minus our average. I don't know what exactly our average is, but you can calculate that. 3 minus our average squared. Now this is where that sigma comes into play. Sigma means sum of, so that means it means plus. Then we put in our next one, 4 minus x bar squared. Again, plus 7 minus x bar squared plus 11 minus x bar squared. There we go. That is the top part of the calculation. You would put in all your data points. You would fill this up with all your data points, and then you will be good to go. So I recommend solving each part out. So let's say you get a number out of here. I don't know, whatever, just a number, 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 and then just add it all up. Okay. And then you will have a one number, whatever it is, for the top. Then you just do your other stuff is just simple from there. You plug in your 4 for n, so 4 minus 1 is 3. Then you take your number divided by 3, put it in the calculator, get a number, then square root that number, and that is your standard deviation. That is how you approach standard deviation for every single problem. Your lab practical is going to require you to do standard deviation. It's a large part of your grade. And if you can figure this out now, it will really help you when studying for that lab practical. So keep that in mind. This is how you do standard deviation. And don't forget it. Awesome. All right. Now, some other things I want to go over that may not necessarily be that important, and you might have a grasp of it already. Experimental error. You will have to include this in your post-lab calculations. So technically, it is important. So to calculate your percent error, okay, you're going to take your experimental value, your EXP value, minus your accepted value. And remember, your experimental value is something that you obtained experimentally. You performed the experiment, you got this. This is what you measured. Your accepted value is something that someone tells you. For example, someone tells you an electron weighs 1.6 times 10 to the negative 19 grams. That is something that someone tells you. That's an accepted value. Accepted by the scientific community. Okay, so your experimental minus your accepted value. And you put that in magnitude. You're going to take the magnitude of it, so absolute value. Okay, and that is divided by your accepted value. Okay, and what you get from there will be your experimental error. If you want to find percent error, it's the same thing. All you do is you multiply by 100, and that will give you percent error. So this will be important to actually include in your post-lab calculations. So keep this in mind. This will be very important. And you'll use it for a lot of your other labs as well. So this is also keep that in mind. Excellent. All right, that was all the calculation stuff for this lab. So let's continue going through and finishing up the last portion of the lab. Okay, great. So we went over all of those calculations that are going to be important for your lab. So now this is going to be your data sheet, your sheet where you're going to be collecting your data. And you're going to be doing different experiments here. So part A, you're going to make sure there's a part A section in your blue book for your procedure. Okay, follow what it says here up above. Okay, and there's going to be a part B, you're going to be measuring stuff, a part C, a part D, and a part E. Okay, and it asks you here, remember, calculate standard deviation. Refer back to this video to learn how to calculate standard deviation, but that is going to be important, and you're going to want to show that in your post-lab calculations as well. So make sure there's a part A, a part B, a part C, a part D, and a part E for your procedure and observations for each part. Okay, and make sure the safety data, or not safety, but this report sheet is filled out completely, because this is something you will turn in with the lab. Awesome. All right, that was the first lab of Chemistry 1A. I hope that gave you a background on how to approach this lab. It is a complicated first lab, especially as starting out as a new chemistry student, but I'm sure all of you guys can get it. Just follow this video and it'll really help you. And again, we're open in the Learning Center for you to stop by and get some help. If you have any questions, stop by and we'll be there to help you out. All right, guys. Thank you so much for watching, and I hope you guys have a great day. Peace.